So yesterday we started looking at the unit circle, and we saw how it related to the trig function, sine, cosine, and tangent. So today we're going to extend that just a little bit further, and we're going to throw in the reciprocal trig function. So remember, the reciprocal trig functions are basically the reverse. They're basically the flip versions of the sine, cosine, and tangent. So as far as how that relates to the unit circle, if sine of theta is the y-coordinate, then that means cosecant of theta, its reciprocal function, is 1 divided by the y-coordinate. The same thing is true for cosine of theta. Its reciprocal function is secant. So secant of theta would be 1 over x. Likewise, for tangent of theta, if it's y over x, then cotangent of theta, its reciprocal function would be x over y. So we're going to try to use these three reciprocal functions. And we're going to start with secant of 13 pi over 4. So secant of 13 pi over 4. So I wanted to do one like this because 13 pi over 4, we're going to find, is not on our unit circle. If I search all the way around this unit circle, I will find that 13 pi over 4 is simply not on there. And the reason for that is because 13 pi over 4 corresponds to an angle that's bigger than 360 degrees. So the first thing that I'm going to do in trying to tackle this problem is I'm going to find a coterminal angle for this. Because if I can find like what angle it corresponds to on the unit circle, then it should be pretty straightforward to figure out what the secant of this angle actually is. So 13 pi over 4, I want to find a coterminal angle for that. And to do that, I'm going to subtract 2 pi. So remember, we never actually put pi in our calculator because we're dealing with exact values. We want exact values. So we can't ever put pi in our calculator because it gives us a long decimal, and that's not what we want. We want an exact value. So if I want to do 13 pi over 4 minus 2 pi in my calculator, I'm going to put all that in except for the pi. So 13 pi over 4 minus 2 pi is 5 pi over 4. 5 pi over 4. So because it is a coterminal angle, the secant of 5 pi over 4 is going to give me the same value as the secant of 13 pi over 4 because they're essentially the same angle. So let's find 5 pi over 4 on our unit circle. 5 pi. So it's in the third quadrant, 5 pi over 4. So if I want to find the secant of 5 pi over 4, I need to look at the x-coordinate. That's not the x-coordinate. Here's the x-coordinate. Negative square root of 2 over 2. So remember, for the secant of an angle, it's the reciprocal of cosine. So I'm going to do 1 over that x-coordinate. So I'm going to do 1 over negative square root of 2 over 2. So 1 over negative square root of 2 over 2. Let me simplify that a little bit. So remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So if I flip that bottom fraction and multiply by it, it means the same thing. So that gives me negative 2 over the square root of 2. So now that is an exact value for the secant of that angle, but we may also want to go ahead and rationalize that denominator if we wanted this answer in fully simplified form. So remember, to rationalize a denominator, we take whatever radical is on the bottom and we make a fraction out of that radical. We put that radical over itself. Remember, this is really just 1. So when I go to multiply this, let's see what I end up with. Negative 2 square root of 2 over 2. Remember, a radical times itself, that results in the radical being canceled. So we can actually simplify this a step further. We got a pair of 2's here that we can cross out. So our final answer here is negative square root of 2. Now, these are the same exact thing. You can put them in your calculator and see for yourself. Both of these are exact answers. The one on the right here, negative square root of 2, is a little bit more simplified though. Alright, let's move on to cosecant of 510 degrees. So again, the problem with this one is 510 degrees, that's not on my unit circle, or at least it's not labeled as such. My unit circle just goes through 360 degrees. So I need to find what angle that actually matches up with. So we're going to find the coterminal angle again. So find the coterminal angle. So this is the reason why I've had you guys practice finding coterminal angles for 2 days straight now, because it's a pretty big prerequisite skill for this section. So 510 degrees. So let's see what it matches up with. So 510 degrees. So I'm going to go ahead and subtract 360 degrees. That should be sufficient. 510 minus 360 gives me 150. So 510 degrees, that's the same thing as 150 degrees here on this unit circle. So what we can find here instead is a cosecant of 150 degrees. So I'm going to go ahead and write down the definition for cosecant. Cosecant of an angle, at least on the unit circle, is defined as 1 over the y value of the corresponding point. So let's look up here on the unit circle for 150 degrees. So 150 degrees is up here in the second quadrant. And the definition of cosecant uses the y-coordinate of that corresponding point. So in this case, 1/2. So to find the cosecant of 150 degrees, I have to do 1 divided by 1/2. One divided by 1/2. So I'm still going to, we might be able to do this one in our heads, but I'm still going to go ahead and multiply by the reciprocal just to kind of get you in to the habit of it. 1 divided by 1/2 is the same thing as 1 times 2 over 1. And that, of course, is just 2. And that is definitely as simplified as anything can be. Alright, moving on to the last one here. We're going to do a cotangent one as well, just for the sake of completion. So cotangent of 2 pi over 3. This one is in fact on the unit circle. So let's find 2 pi over 3. Aha, second quadrant up here in the top left. So 2 pi over 3. So the definition of cotangent uses both the x and the y value. So to do the cotangent of an angle, I have to take the x-coordinate and divide it by the y-coordinate. So for 2 pi over 3, that is negative 1/2 divided by square root of 3 over 2. So negative 1/2 divided by square root of 3 over 2. So we can definitely simplify this a little bit. Let's go ahead and multiply by the reciprocal. When we do that, we can go ahead and cancel these 2's, and we're left with negative 1 over square root of 3. So this is an exact answer, but it is not completely simplified. Remember, if I want to completely simplify it, I've got to rationalize the denominator. So we rationalize the denominator the same way each time. Whatever radical is on the bottom, multiply by a fraction with that radical on top and that radical on bottom. So we've got negative square root of 3 over 3. Remember, a radical times itself results in that radical being canceled. So both of these are the same. One is more simplified than the other, but both are exact solutions.